All right, and welcome back. So today we are going to be talking about section 7.5, which is all about factoring special products. So previously in chapter 6, we talked about how to multiply special binomials that end up with a special product. This chapter, we're going to be going in reverse. So let's talk about that first example of a type of special product. So previously, we started talking about the perfect square trinomial, where if we had a plus b and that was squared, we can turn it into a perfect square trinomial. Likewise, a minus b, if that quantity was squared, then we can turn it into a perfect square trinomial. This time, we're going to be working backwards. So if a polynomial is a perfect square trinomial, the polynomial can be factored using a pattern. Remember, previously we went through, hey, if we start with a plus b squared or a minus b squared, we can derive that into this special setting of a squared plus 2ab plus b squared, or if it had a subtraction sign in the middle, it was a squared minus 2ab plus b squared. We were able to figure out that we could still FOIL and multiply these binomials and still get up with the same answer. So it's just a little bit of a shortcut. Well, now, in this chapter, we are working backwards. We're going to be starting with a potential polynomial, we call it a quadratic, and we're going to be trying to work backwards to see if we can get it into that special setting. So let's go through an example, and I'm going to be providing some insight along the way. So we have to determine whether or not 4x squared plus 20x plus 25 is a perfect square trinomial. If it is, then factor it. If not, we're going to have to explain why. So what we're going to have to eventually do is find a, b, and then 2ab. So to find a, we're going to look at our first term. Our first term is 4x squared. We're going to look at 4x squared, and we're going to take the square root of that. Well, the square root of 4 is 2. The square root of x squared is x. So this is a perfect square so far. Then to find our b, we're going to look at this constant value, this last value, 25. We're going to say, okay, what is the square root of 25? Well, we know it's going to be 5. So the last term is a perfect square. And in order for us to get the 2ab, what we need to do is take the product of a and b, so now 2x and 5, multiply them together to get the product, that's 10x, and now we're going to double it. So that's 2ab. We have 2 times 2x times 5, that is indeed 20x. And you're going to see that since we do get 20x, which is what's in the middle, this is going to be a perfect square trinomial, and we can factor it as 2x plus 5 squared. Now, we technically can go through the grouping method in order for us to do this. We can, I'm just going to go through one example real quick, but it's going to be a little bit long for us, but it's okay. We can still figure it out. So we have 4x squared plus 20x plus 25. The grouping method asks us to multiply the a and c value, which is 100, and we want to find factors of 100 that add up to give us 20. Well, that's 10 and 10. And notice that it's a perfect square, right? 4 times 25, that gives us a perfect square. So anytime that you multiply two perfect squares together, guess what? You're going to get another perfect square, right? Crazy. So we're going to go back in, replace that 20x with plus 10x plus 10x plus 25. We're going to go through that grouping process. We're going to factor out what we can. In that first set, I can factor out 2x, and we're left with 2x plus 5. In this second set, we can factor out positive 5, so I write plus 5, which is going to be 2x plus 5. We want to aim for those matching parentheses, and it looks like we do have them, which is great. So our answer is going to turn into 2x plus 5 times whatever was on the outside, which happens again to be 2x plus 5. Now, since it's the same thing multiplied together, we technically can simplify to be 2x plus 5 squared, which is exactly what we ended up with. So we still can use the grouping method. It's just going to be a little bit longer for us to identify. But if you want to do that, by all means, go for it. Let's now determine whether 9x squared plus 25x plus 36 is a perfect square trinomial. If it is, we're going to factor it. If not, we're going to have to explain why. So we have to find our a, b, and then double the products of a, b. So we look at 9x squared, and we're going to take the square root of that, and we do find that we get 3x, which is good, which means that that first term is a perfect square. We're then going to look at that second term, the c term, and we're going to figure out that, okay, that 36, that is a perfect square because the square root of 36 is 6. But now we're going to find the product of 3x and 6, which is 18x, and now we have to double it. 18x times 2 is 36x, which is not the middle term. We end up with 36x. That's not what we have in the middle, which means that we are going to stop because this is not a perfect square trinomial. That should be a plus sign typo. All right, so again, we could see if we can factor this. It's just not a perfect square trinomial, right? There are going to be some times where we're going to be asked, okay, like identify a perfect square trinomial and identify how to actually go about and just graph a general quadratic expression. But for right now, we're just trying to talk about identifying those perfect square trinomials. Awesome. So with this, please work on problems 1 through 3 on the guided notes and resume when we're ready to move forward. So the second type of perfect product that we were working with, or special products, I should say, to me, they're perfect, but that's okay. It's the difference of squares, where we had a plus b times a minus b, and we were able to write that as a squared minus b squared. Well, now again, we're working backwards here. So if a binomial is a difference of perfect squares, it can be factored using the pattern. So again, let's recall, we started with a plus b times a minus b, and we transformed it into that difference of perfect squares. Now this chapter, we're going to be going backwards. We're going to try to identify a difference of perfect squares, and then we're going to factor it in. So let's go through an example. So determine whether 64x squared minus 25 is a difference of perfect squares. If so, we're going to factor it. If not, we're going to explain why. So we have to determine if the binomial is a difference, right? We have to see if we have that subtraction sign. Remember, the difference is the answer to a subtraction problem. So we have to identify, okay, does it have a subtraction sign? Yes, it does. The minus sign indicates that it is a difference, which is great. Now we're going to have to find a and b. So similarly before, we're going to take 64x squared, and we're going to take the square root of that, which is 8x. So that is a perfect square. Then we're going to take 25. We're going to take the square root of that, which is 5. So that means now that 64x squared minus 25 is a difference of perfect squares. So it can be factored as 8x plus 5 times 8x minus 5. Now, again, we can use the grouping method here. It's a little bit unorthodox, but let's go through it together. We have 64, pardon my error, 64x squared minus 25. And we want to factor this. So we're going to have to multiply the a value, technically, with the c value. So we do 64 times 25. So 64 times 25 is 1,600. So what we need to figure out is, okay, I know it's going to be a negative 1,600 because of that minus sign with that 25. So we need to think of, are there factors that when multiplied give us negative 1,600 but add up to 0? Because there is no b term here. There is no term that has the variable x. We have an x squared and a non-variable term, but we don't have what we call the linear term. We don't have that term that has only x as our variable. Well, fortunately, 1,600 is a perfect square. The square root of 1,600 is 40. So what we can do is we can go back into our problem, add 40x and subtract 40x minus 25. And again, these numbers are going to get big which is why we try to identify if we have any special products. We're going to go and see what we can factor out of 64x squared and 40x. I believe we can factor out 8x. When we do that, we end up with 8x plus 5. On the right-hand side, I want to get 8x plus 5, so I'm going to work a little bit backwards here. I know we're starting with negative 40x, and I need to get to positive 8x. Well, in order for that to happen, we have to divide out by negative 5. Let's just double check that works in the other term. We started with negative 25. I want to get to positive 5. So that means negative 25 divided by negative 5 is indeed positive 5. We're going to factor out what is common. So we end up with 8x plus 5. That was the common set of parentheses, the matching set. And then 8x minus 5, which is what was on the outside. And you're going to notice we end up with exactly the same answer, knowing it was a difference of perfect squares. Okay, so we can still use this process. It's just going to be a little bit tougher and a little bit longer, but we technically still can use it. It's just going to be tough because we don't have a B term. And that's what throws a lot of people off, is that, oh, whoa, I don't see that B term. I don't know what I have to add to. Well, if we don't see it, it doesn't exist, it's 0. So notice how positive 40 minus 40 gave us 0, which is how we did not end up with that B term. Awesome, let's go through one more example. Let's determine whether 4x squared plus 25 is a difference of perfect squares. If so, we're going to factor it. If not, we're going to explain why. Well, the first thing we need to do is determine if the binomial is a difference. So we look at the sign right in the middle, boom, we see it's an addition sign. So the plus sign indicates it's going to be a sum, because an answer to an addition problem is a sum. It's not a difference. So we're going to stop. The binomial is not a difference, so it cannot be a difference of perfect squares. It also doesn't have a greatest common factor, so 4x squared plus 25 cannot be factored. And if you were to go through the grouping method, you would find that there are no factors of 100 that when we add them together gives us 0, but multiplies together to give us 25. So we find that that is not going to happen. Awesome. Great job with this, kiddos. With this in mind, please work on problems 4 through 9 on the guided notes. Y'all are doing super duper well. Keep making yourself proud. If you have any questions, please let me know, and I'll talk to you soon.